Hi everyone, my name is Tiffany, and today I'm going to talk about an industry analysis on AI infrastructure. Specifically, when it comes to problems, I'm very interested in the AI infrastructure layer and the AI foundation model layer, and knowing how these two interacts, right? Like the tokens, the data science, the machine learning, and the AI infrastructure. I think is a very personally, it's a very fulfilling project for me. And so I'm going to do an industry analysis on AI infrastructure. And the reason I did this, and I was focused on financial, was just because. Um, Sometime last year, when I was seeing all these hedge funds building out the AI infrastructure, because I have a distribution edge in hedge funds, I figure out that I figure out a potential business idea being an AI infrastructure value-added resale for Asian hedge funds. And I was very much focused on three things. One is TCO, second is the supply chain, and third is hardware software optimization. By the time I was solving the problem of supply chain, like I learned something fundamental in supply chain that made me like give up my idea. And I think that's always a good thing. You need to reason through your problems. And if your first principle hypothesis is challenged, you should just learn how to give it up. So yeah, I'm going to talk about how much does a 1 gigawatt cost, the TCO of 10K GPUs, and token inference, test time compute, compute contracts, lessons learned from OCP. So fun fact about OCP was I reached out to a couple of conference in the US, and then to OCP I kind of asked if I would love to be a student volunteer. They came back and they said that, oh, you're a student. As part of charity work, we would like to sponsor your flight and your hotel to Silicon Valley. It's crazy. This is like my first American experience, and that was very fun. Okay, 1 gigawatt factory. So earlier this year, I talked to one of the guys in Google, and he was like, "Tell me how much you think a 1 gigawatt factory costs." And I said 68 billion. That was a number that I got from Semi Analysis. And he said that was way too big. And what's happening in the industry is that it's such a multi-player game that no one fully knows how much does it cost. But according to Epoch AI, it's around 37 billion. And you can see that servers is like 60% of the cost. And this is the capital expenditure upfront. And for Analyze, you're making assumption that GPU can be depreciated for 5 years, 4 to 5 years. That's a standard. But recently, CoreWeave announced that they had A100s that is contracted between 2020 to 2029. And then the facility is 15 years. And my understanding is that if you sign a lease for a data center and you get 1 gigawatt, you only get 1 gigawatt. That's my understanding based on what I talk with the industry players. So if the power density of the racks increase, then you have to refit the entire uh, data center, and you might have excessive space, for example, because it's power constrained. So yeah, and total is around 7.6 billion, and the operational expenditure, energy, taxes, labor is like 900 million. And I'm going to talk about token inference. Now, I get all these information from long yield, value add, and like there's just a lot of content on Substack recently. Like all these stuff that I got that I've done over the years, it's like a lot of it from Substack, from Twitter. But the reality is there's just so much information out there, and and there's so much of these crazy headline news, you really have to like be careful about it. Um, so I got this information from Long Yield and Gemini, and they kind of exaggerated at first. The 2026 cost of tokens is like zero point 0.1 for the input. When the reality, this is a baseline, uh, on the baseline flagship model, because OpenAI also offers very cheap tokens for like their Flash model that is, you know, cheaper. So sometimes these headlines kind of like exaggerated. Oh my God, tokens went from 2.5 to 10 cents in 18 months. AI is a bubble, etc. But like you have to look at the details. So this is a token inference. The cost of 1 million token in OpenAI for its flagship model was input output was this much. The market size of inference is expected to grow like to 255 billion. And these are the open weight models where, V3 is a traditional, you put compute in the pre-training. R1 is where you put compute in post-training on reinforcement learning and implementing test time compute, putting more thinking during the inference period, which was quite a sensation, I think, because it was just a couple months after OpenAI announced their O3 model. So yeah, these are very smart people. And then Quen, and then Kimi. And Kimi just like scale 2.8 trillion parameters. I'm not even sure that you can fit in like how many GPUs needed to fit that in. And given that it's open weight and enterprises have to host these open weights in their company, I think it's quite difficult. Is it, you know, viable strategy? I'm not so sure. So yeah, this is the cost of tokens, and generally you can see that it has went down. Um, and then I'm going to talk about TCO modeling. This is was I was cold calling from personal hedge fund networks. And what I do is just I would look at the SEC filing, and then because I'm jobless, right? So I just cold call, and I was like, oh, I'm looking for a job, and then sometimes they picked it up, and I share as much information as I learned from my industry experience, and they learn something from me too. So this is 10K GPUs. When in July 2025, back then when I was talking to hedge funds, their clusters was around 10K at least. And I was talking to a neo cloud, and he said that roughly he thinks that there's only 30 companies in this world that's making money, making cash flow positive money from 10K GPUs. I'm not so sure what's happening right now. The world has changed so much, and these are the numbers. And I talked to one of the neo clouds in the machine learning systems conference, and he thinks like the numbers is a bit off. But yes, I'm an total outsider in the industry. I use PyTorch Atoms, and what I did was, Meta's one was 24K, so all I did was prorata it one by one, and then and I gave an assumption of 9.1% for the weighted average cost of capital, which is roughly the weighted average cost of capital of ManHL, a hedge fund that's public. So this is what I did. And you can see this is a TCO for 10K, and this is the electricity cost, which I think it's quite optimistic. 1.25 PUE, 90% utilization. Um, and and what I was trying to say is that, okay, instead of just getting it from the OEM, what happens if you just like take it server by server, piece by piece, which is what I think Google and the hyperscalers are doing. And like if the OEM markup is roughly 30%, ODM is I think 1%. So it's actually you get to save actually a lot of money. And then this is the operational expenditure. So that was a thesis I was trying to build. And there's like a lot of stuff as well that I did. And now I'm going to talk about the recent news. And I came from finance. Everyone is always like, it's a bubble, it's a bubble, it's a bubble. They look at the circular financing and they're so scared. And I think the mistake I made is when I went to Silicon Valley, I was like, is it a bubble? Is it a bubble? And like it pisses some people off. And then they have to explain to me that it's not because they just don't understand, right? The circular financing thing is just a function of the incentive system. If AI labs are rushing for compute, they need to make sure that NVIDIA is personally invested in them so that they're interested in like giving compute to these people, right? And NVIDIA wants a world where power is distributed. It's not just with hyperscalers who are building their own chips. So yeah. So this is what happened. There was a expansion in credit default spreads, even though hyperscalers have better balance sheet and people got panicked. I was like, oh, so it's widening, it's widening. And Gavin Baker actually wrote something really nice here, and he articulated that the spot pricing of renting GPUs is double of the contract pricing. So this means that, once things settle down, there's an acceleration of cash flow. It means that hyperscalers are under earning now. So clients who actually make those contracts in 2024 and 2025 is actually over earning. And there's been a couple of private companies that says that as the contract rolls off, they're willing to pay spot. They're willing to pay 2 times. So there's just a lack of supply and compared to demand. And expectation is that by 2028, there's like roughly 25 to 35 gigawatt of built out in the United States and 10 giga. And I'm pretty sure OpenAI kind of mentioned 10 gigawatt, right? Which is like a huge number. And that's like what? For 1 gigawatt, let's 37 billion. He kind of said it was 50 billion. And so consensus estimate is like it's like 1.5 trillion of capital expenditure. And compared to the $500 billion debt, there's an expectation there's like a 1.2 trillion of operating cash flow. People are just really worried about the AI infrastructure build out. So that's pretty much it. And what's really great about this is that a lot of these stuff was just on the basis of transformer as an algorithmic model. So before transformer, it was the recurrent neural nets. And then this was Transformer was the predominant architecture. And if there's a new architect, and even within Transformer, there has been a lot of changes, whether it's like pre-training, post-training, RL, um, and if there's another algorithmic change, all these data center configuration is kind of screwed. And why? Because even test time compute, right? I wrote about this. The effect of test time compute on data center dynamics. Algorithmic development can have ripple effects on hardware, data center, and physical infrastructure. It changes uh, the needs, the temperature needs, and etc. So yeah, I wrote a lot of stuff on my blog, and in terms of stuff specifically related to AI. And yeah. And I want to talk a bit about what I learned from Open Compute Project. So Open Compute Project is the conference that I went to. Well, first of all, they really wanted young people. There's not a lot of young people in the AI infrastructure industry, so they're hiring. The second thing is like it's just a huge shortage, right? Hard drives are sold out for 2 years. SSD prices are up. Generators are in a 2-year back orders. And in that entire gigantic conference, 80% of the business is like the hyperscalers, the big tech. And so I talked to one of the hyperscaler and he's like worried about risk, right? Putting too much money. So when they canceled the data center, immediately a competitor filled the gap. So and then demand surge afterwards. So there's a lot of risk management that you kind of have to do in this case. So that's like the biggest thing that I learned in Open Compute Project. So yeah, that's it about me and I hope you enjoyed it. Thank you.